Hi friends, this is Tamur. Welcome to my channel, The Cloud Security Guy. In case you're new here, I talk on a weekly basis about things like cloud security, artificial intelligence, and general cybersecurity career advice. So today we are continuing our CCSP crash course. If you're not aware, then the CCSP is the Certified Cloud Security Professional, which is a certification from ISC2, who the same people who made the CISSP examination. It's one of the hottest cloud security certifications around, and this is a completely free CCSP crash course covering all the domains. We are currently at domain 4, and if you're not aware, then we've already covered domain 1 to 3. You can go back and check it. And so let's move ahead. Before we move ahead, of course, let me give the disclaimer which I always give, that this is a crash course. If you've not done anything before, then this will not make you magically pass the examination. You need to make your notes, you need to read the books, you need to practice before the examination. The purpose of this course is for revision and for clearing up your concepts. If I can help you, wonderful. It's always good to have a little bit of a revision before the examination, but I don't want you to make this the only way of preparing for the examination, guys, please. Okay, and before we move ahead, please do like and subscribe to this channel. That will really help the channel to grow and meet the maximum amount of people. So today we are at domain 4, which is cloud application security. The CCSP examination has around 6 security domains. It's called the CCSP Common Body of Knowledge. They are basically the 6 areas that you must master in order to pass the exam. These are the CCSP domains, and this is like what is the percentage. So today we're going to be talking about domain 4, which is cloud application security. It comes at around 17% of the CCSP exam, and it covers the most critical application security concerns that are in cloud environments. So we're going to cover some of the common cloud application security issues. What are the significant, like what are the vulnerabilities which happen? And this one of the key areas is the secure software development lifecycle, SDLC. We're going to learn about the phases and how to secure them. Okay, I mean, so we're going to look at all of them. We're going to learn about static and dynamic application security testing, SAST and DAST, the pros and cons of each, black box, penetration testing, all those things. This is quite a heavy, what do you call, domain, and a lot of questions do come from there. So pay attention and let's go ahead. So first of all, let's move to cloud development basics. As a CCSP candidate, it is very important that you're familiar with the basics of cloud application development. You have a strong understanding of the common issues and vulnerabilities that happen throughout the software development lifecycle. And the starting point of is understanding APIs. And the key difference between an application development in the cloud and in traditional on-prem IT is that cloud development relies heavily on the usage of APIs. Because cloud environments are strictly, accessible from the web. So the cloud service provider, they make APIs accessible to cloud developers so they can manage, access, and control cloud resources. But what is an API? So API stands for Application Programming Interface. It's how they talk to each other, applications, okay? And pretty much it forms the backbone for how applications work nowadays. I mean, whether it's on-prem or cloud may have more APIs, but everything is now APIs pretty much, more or less. Okay, so this is what it looks like. Basically, it's a mechanism that allows two software systems to interact. They're not going to plug in directly to each other, right? If you have two applications, one is over the web, one is internal, they don't talk directly to each other, but instead they exchange messages through an API. So basically, there will be the request sent, and the application will send a response back via the API. So why is that needed? If you want to look at it from a simple example, imagine you're sitting in a table in a restaurant you have a menu, and the kitchen is the system that will prepare your order. It's going to give the response. What is missing is the critical link to communicate your order to the kitchen and deliver your food back to the table. That's where the waiter or the API comes in. The waiter is the messenger or API that takes a request on order and tells the kitchen or the system what to do. Then the waiter delivers a response back to you. So in this case, it's the food. So you understand it. It abstracts away. You don't need to worry about what the chef is doing, how you have to tell him. You just have to order, and the waiter will do everything. So this is how it works. And we talk about APIs, pretty much the two most common ones are Simple Object Access Protocol, SOAP, and representational state transfer, which is REST. They both work across HTTP, and they both like VLAN and WUS. We're going to see the differences, but you need to understand like both of them, how they work and what are the key differences. So let's take a look. So Simple Object Access Protocol, SOAP, it relies heavily on XML. It was designed, it has a very rigid format. It was designed to ensure that systems like built in different languages or platforms, they can communicate with each other in a structured format. Basically, SOAP, what it does, it encapsulates data in like an envelope and then uses HTTP or other protocols to transmit the data. One of the major problems is it's usually it only allows usage of XML formatted data, and it's pretty much the long standard solution for web service interfaces. Today, nowadays, it's usually used for like legacy applications or where REST is no longer like feasible to use. But it's very rigid, and sometimes people like that because it forces it to use a specific format. Okay. West. So West is like pretty much it's become the standard. Like people used to complain about SOAP. It's like a SOAP. It's like a complicated, slow, and rigid protocol. And West is it's not like a protocol, but it's like a software architecture style applied to web applications. And it's very flexible. Okay. And it's very efficient. And SOAP uses XML, right? SOAP, but West uses smaller message formats like JSON. So even the messages are smaller, and it's much faster. That's another one of the major what do you call advantages that it has. And it uses like it has a very certain formats, like five architectural requirements are there for a system to be considered following the rest, like client server architecture, statefulness, cacheable, layered system, and uniform interfaces. So basically they force the system to talk in a certain way with each other. You don't need to dive too deep into rest and SOAP, just understand the high level requirements. That SOAP relies heavily on XML. West is more flexible and it's more commonly used now. It uses like smaller messages, like JSON is there. It's faster than SOAP. Okay. And okay, so move on. What are the common cloud application issues? As a CCSP, it's your responsibility to help your organization have awareness of risks and issues when they are migrating applications to the cloud. So first of all, let's talk about application portability. So traditional on-prem applications, they're designed to run in a certain way, and they are not developed with cloud environments in mind. So when migrating things to the cloud, security is not exactly the same as you're used to on-prem. Some on-prem applications are designed in such a way to work with a very specific set of security controls, which are there in your data center. And when you move these to the cloud, some of these controls may need to be reconfigured or redeveloped or reaccommodated to work in a new cloud-based solutions. Okay. And you have to understand this. Like if you're migrating like some old legacy application to the cloud, and some of those on-prem controls may not be present there in the cloud, so you need to look at that. Second is integration. So when moving to a cloud environment, your developers and admins, they don't have the same level of control, and so performing systems and application integration without having the full access to all the supporting system and services can be very complicated, right? So cloud customers, they have to rely on the cloud service provider for assistance, and that may lead to delays. It might even increase the project cost, right? You can use the cloud provider APIs that can help, but overall, like integration is something you need to keep in mind, and that sometimes does become an issue. What else? Okay, environment challenges. Now, the deployment model, whether it's public, private, community, hybrid cloud, it determines the level of multi-tenancy, and it may also impact like the application development considerations. You need to think about this, like what sort of model am I using, PaaS, SaaS, IS, and what do you call it may also includes like it determines what sort of challenges are there. Like in the IAS, you might have access to the logs, right? But in a SaaS, you might not have access to the logs. In PaaS, you might or not have access to the underlying operating system. So these are all the environment challenges you need to think about. And lastly, insufficient documentation. I mean, if you have ever done any migration, a lot of applications do not have sufficient documentation. It becomes a big challenge when you have to migrate these applications. You have to think about them. So these are the common cloud application issues which happen when you're migrating stuff to the cloud. Okay, and what about the vulnerabilities? So the vulnerabilities, these are the categories of vulnerabilities which come in: access control, internet-related vulnerabilities, data storage, and misuse. Okay, and and usually they are linked with some characteristic of the cloud. So let's look at the first one, which is access control. So access control, if you remember, we talked about the cloud. It is self-service, right? So that means cloud users can just access cloud services whenever they want, and this sort of access makes identity and access management very important. So you need to make sure that applications are developed and implemented with the principle of least privilege. You have to keep in mind that users only have access to what is needed. So that's why zero trust comes in. You need to make sure that all those things are there. Okay. Second one is internet related vulnerabilities. So we talked about the cloud having broad network access, right? It's available from anywhere, and you can pretty much access it through the internet protocol. And the problem is it becomes an untrusted network. So what does that mean? An untrusted metric. So the same common internet related vulnerabilities, like denial of service, man in the middle attacks, all of them you have to consider when you're thinking about cloud computing. Okay. And you need to make sure those controls are there, and those controls have been put in place. Okay. What else? Now, data storage. So if you remember the characteristic of resource pooling, so that one hardware resource is shared amongst multiple customers, right? You have multi-tenants. So what does that mean? The data of one cloud customer is sharing resources with another cloud customer, right? And usually cloud service providers, they put in very strong logical controls between the tenants. But at the end of the day, you are sharing a physical machine, right? And sometimes you might have legal or regulatory requirements, and that you have to force that only one tenant can be on one machine. And you need to put in your other controls also. You need to put in things like encryption, and making sure that encryption is there. So even if that somehow some compromise of data happens, that persons cannot access that data. Okay. And lastly, the misuse. So the misuse is, we talked about measured service, right? The cloud is like a metered service. It's like electricity or water. You pay for what you use. But what if some hacker compromises your systems and then runs up the bill, right? He's maybe using it for mining crypto, he's using Bitcoin and all that, and it's racking up the bill. So you need to make sure those controls are there. You have alerts set in, and you have like a threshold set in that no server can exceed this much amount, no billing can exceed this much amount. So all these controls you need to take into place. Okay, secure software development lifecycle. Now, streamline, and this is something I'm sure most of you will be familiar with, and I mean anybody who has done a little bit of IT work, he is familiar with this. Secure application development. Anytime you're developing an application, it requires like some sort of methodology, right? Some sort of process from to get you from the concept to the finished product. So SDLC is the series of the steps that you follow to build, modify, and maintain computing requirements, right? And you need to take into account your business requirements. What are the You need to gather those requirements, develop applications, make sure they're testing. So all these things you need to take into account. And I mean, I'm sure you must have, if you've ever prepared for any certification, this topic must have come up, right? So these are at a very, very high level, and you need to think about these processes, which is like planning, defining, designing, developing, testing, deploying, and maintaining, right? The planning one, it's the most fundamental stage of the SDLC, right? It's usually called requirements gathering. The planning phase is where risks should like be identified. Your project team should consider what can go wrong, what you can mitigate or lower the impact. Like if you're thinking about launching a banking application, and you know that credit card information will be there, so then you need to think about maybe PCI DSS compliance controls are there or not. Defining. So what's defining now? Defining, you this sometimes this phase is referred to as requirements analysis. So during the defining phase, you use all the business requirements and feasibility studies and with stakeholder input that you got in the planning phase, right? And now you start defining your product requirements, and what sort of hardware and software is required, what sort of development environment is needed, what sort of programming languages. And this is also where you define all your application security requirements, right? What sort of tools and everything is needed to make sure, like if encryption is needed, what sort of access control is needed. Next phase is designing. So designing phase is where you take your product requirements and the specifications, and you turn them into actual design plan, right? Usually it's called a design specification. Design is where you guide your actual development, you before the actual development starts, right? And this is where threat modeling happens, and you integrate your risk mitigation, like the things you talked about during the previous phases, and you start putting those controls into your formal designs. Okay, next phase is the development phase. So here, software developers, they start getting happy because after weeks or months of planning, finally they can start to write some code, right? During this phase of the SDLC, your development team wakes up the like all the design phases and everything. They start coding, right? So during this phase, they start conducting peer reviews. They check the flaws, make sure that it's working as they want to work, right? And this is, of course, where you start your security testing. You conduct static code analysis, security scanning of each module, right? And of course, next step is the testing. Once the code is developed, the application enters the testing phase. During this phase, application testers, they want to verify whether the application is working as desired and according to the requirements, right? You want to uncover all the flaws within the application and report them to the developers for patching. And this continues until everybody is like happy, right? As a completed application, now security testers, they have more tools, right? Now they can, instead of relying only on static code analysis, now you can start doing application penetration testing, dynamic analysis to identify flaws. that only you can find out once the code is executed, right? We're going to discuss about static analysis and dynamic analysis further on, but just keep that in mind where it happens. Okay, and I think what do you call testing is very important, right? It's one of the most crucial phases of the SDLC. You have to make sure that the proper plans are there and everything, right? And once it's done, now we move on to the final phase, which is deploying and maintaining. So once the application has passed the testing phase, it is ready to be deployed for customer use. And you have things like alpha, beta, general availability, and everything. But during this maintaining phase, it goes through like this is where you start security patching and ongoing maintenance, right? And from a security perspective, you need to make sure that like the data is being put in the cloud environment, what data is being, how it's being kept, how it's being deleted, the SLAs, all those things we need to keep into mind, which we are talking about for an actual production application. Okay, now that we've looked at the SDLC, the final stage of the LCC we talked about, right? Deploying and maintaining. So this is where this is like a very, very important phase, because we're talking about maintaining an application after deployment for the full lifetime until this application is decommissioned. And a very, very important part of this is configuration management and application versioning. What is configuration management? It's basically tracking and controlling all the configuration changes to the systems and software. And versioning is the process, of managing the multiple releases of an application. Usually you have like small changes that happen over time. And configuration management is like a major consideration for any development team in any environment, right? You have to make sure they're properly configured and it's not breaking any other application. And especially in the cloud, where systems spin up and spin down very, very quickly, configuration management becomes an even greater concern. Like in traditional data centers, like you used to make changes directly on the servers, right? Cloud operate environments, they operate at massive scale. You can't really deploy manually, right? And it's this is where all the automation comes in. So you need to make sure that everything is being updated, tested automatically, and the consistency is there. And for tracking like source code changes for release management and everything, people use things like GitHub version control software for release management. And these version control tools, they are used for managing their code development for releases. So you have to make sure this is how it's tracked. I mean, anybody who's used GitHub know how they work, right? Okay. So, and there are many open and commercial tools are available. I mean, and most, even you don't need to use like third party software. Most cloud service providers, they have things like solutions natively built. Okay. All of them are used, and you can literally find out if anybody has made a single change within a line of code. Developers use these tools to monitor and maintain system and application configurations, right? A centralized version control release management tool. So this is how it's used. Okay, so now we've talked about SDLC and how it works. Now let's talk about the different methodologies. While the steps remain the same, there are many methodologies or models exist. Two of the most commonly referenced one are waterfall and agile. I think everybody must have heard of this one form or another. Waterfall. So waterfall is the oldest and the most strict. Sorry, I just saw it's written metadata. It should be waterfall. Apologies for that, guys. It should be waterfall, not metadata. Waterfall is the oldest and most straightforward SDLC methodology. In this model, what happens? You complete one phase and then you continue on to the next and to the next and to the next. Basically, you're moving in sequential order, right? Flowing through each step of the cycle from beginning to end. And each phase of this model, requires the previous it requires the previous phase to be successfully completed. And there's no going back, because waterfall doesn't flow up, right? And it's easy to use. Tracking and measuring progress is also easy. And what do you call it's usually, there is a reason it works, because it is very effective, right? And you don't need to involve the customer until after everything has been tested. The disadvantage, of course, it's rigid, right? You need to make sure the requirements have been fully developed early, and because they can be very difficult to change, right? And products may take longer to develop, because you need to really wait until the end to get like a working pilot. And it relies very little on the customer and end user, right? Because customers might feel like left out, and testing is delayed late until the process. So, and because of this, issues may build up which could have been identified early on. So that's why something else came along, which was agile. So what is agile? Agile is like the new kid on the block. It came in the 90s, but now it's become very, very popular. Anybody who's been like, you've worked in any IT company, you must have seen this adoption of agile, right? The way if you've been working with Jira and all that, sprints and everything. So instead of proceeding in agile methodology, instead of proceeding in a linear and sequential fashion, development and testing happen simultaneously and like cyclically. So it's separated into sprints. And what happens is each sprint produces a release that can improve upon the previous release. With the agile model, the whole goal is to move very, very quickly and to fail fast. Create your first release, test it, fix it, and then create your next release fast. So it's very, you can understand the advantages, right? It's flexible. You can move from one phase to the next without worrying whether the previous phase isn't perfect or complete. And time to market is much quicker. And it's very user focused because you're getting a lot of feedback, and the risks are reduced because the way the iterative nature of agile, because you're getting feedback very quickly, you can quickly put in like fixes, right? The problem is it can be challenging to apply in real life, especially larger projects which have many, many stakeholders. And the end state is less predictable than waterfall. Why? Because with agile, you iterate until you're happy, right, with the end result. And it requires a very high level of collaboration between developers, customers, and stakeholders. This challenge can be a problem because sometimes you have politics, sometimes you have issues happening, which can really cause a lot of problems with getting the feedback. And in this side of things, agile might cause you problems, and it might not be the best way to go. Okay, so now we've looked at it. We looked at it at a high level. Let's move on to cloud development vulnerabilities. Now you need to understand as a CCSP the common application vulnerabilities and how you need to use threat modeling to find these issues. So you're gonna walk through like all the common vulnerabilities. If you've ever been familiar with the OWASP, the Open Web Application Security Project, it's like a common database of all the common issues. So we're gonna discuss using that, and you will find that there are a lot of overlap between application security issues and the cloud application security issues, like the on-prem and the cloud. But because the application issues don't really change, right? But you need to understand it as a CCSP for the purposes of passing the examination. So what we're going to do is we're going to look by one, each of them to understand how it falls. Okay, so let's go ahead. Okay, first, injection attacks. Now, if you've ever worked in application security, you would have heard of SQL injection, right? And the broader SQL injection falls under injection attacks. They are a broad class of attacks. What happens? An attacker basically sends untrusted commands or inputs to an application. The application processes the untrusted input as part of it thinks it's a valid input, and then what happens? It alters how the application is executing, and in the backend something else gets executed. You can get control over an application's program flow, unauthorized access, even full system compromise, right? This is the reason injection attacks like SQL injection, code injection, cross-site scripting, these are very, very dangerous and also very widely spread, right? So many free tools are there which can easily let you know. You have to protect against this by making sure your application does not have high risk, high privileges, right? And by most of all, by performing input validation, making sure that all the input is checked and approved by the application prior to processing, making sure no unauthorized input is there and unauthorized characters are there. Okay, what is this there? Broken authentication. Now, broken authentication is quite simple. Basically, it allows an attacker to capture or bypass the authentication mechanisms to assume the identity of like an authorized user. So basically, you get the same privileges as an authorized user. It can occur in various ways, right? Like you can allow weak passwords that can be guessed, not terminating an authenticated session when a browser is closed. So by the time the next guy logs in, it lets you log in, right? If you're using like a public computer to check your bank account, but instead of clicking the sign out, you just close your browser. And if the site is not programmed to time out, then the next user who can potentially open the same browser, it'll get access, right? So these things you need to enforce, like multi-factor authentication, password strength, session timeout. You need to monitor it, brute force attacks. All these things you need to, SSL needs to be there. You need to make sure that all the token IDs and the session IDs are encrypted. Use things like a web application firewall. They can support and make sure that other authentication mechanisms are there, right? So this is how broken authentication works. Sensitive data exposure. I think this is pretty straightforward. It's pretty much exactly what it sounds like. Most web applications, they collect, store, and use sensitive information, right? Like PII, cardholder data, and they do not secure the sensitive information, which can lead it to get exposed to unauthorized parties, right? Most of the data protection principles we learned about earlier, like encryption, hashing, all those things, they need to be applied here at rest and in transit, wherever sensitive data exists. I need to make sure the application also need to check for and enforce secure communication methods when they're exchanging like sensitive data with browsers. Okay, what else? XML external entities, this type of attack. So external entity attack, it occurs when XML input, it contains a reference to an external entity, and what happens is this is processed by an application without passing it without checking it, what sort of input is there. So we don't want to deep dive too much into it, but you should understand that it can lead to data theft, port scanning, even denial of service, right? And the best way to do that is to disable document type definitions. It's a type of XML specific characteristics. You can look at it if you want to take a look just for the purpose of the exam, but try to understand what this attack is, what it does. Even OWASP, they have a detailed description of this, and you can look at it if you want to. Okay, we talked about access control, right? And now this is what we're going to talk about: broken access control. So access control is basically making sure that people aren't able to act outside of their permissions, right? Broken access control, then, if of course, it's the failure of those access control mechanisms to properly limit or control the access to resources, right? Like people can do unauthorized privilege escalation, bypass your access control policies. They can modify the URL or other settings, right? They can manipulate data to gain access to unauthorized, like cookies and all that. So prevention of broken access control, you people check it during the testing phase, right? But it goes on, and you need to have both static and dynamic analysis techniques to help you identify weak access control mechanisms. And you should also have things like penetration testing happening on to validate all those things are there. But it's very, very important. Yet you need to have like all those mechanisms there. Like even detection controls should be there. Like somebody becomes an administrator, you should immediately get an alert, right, telling you that some issue has happened. Okay, what else? Security misconfiguration. This is pretty straightforward, right? It's like when systems or applications are not securely configured, and like default credentials are there, default passwords, admin, ABC123, use of insecure default configurations. Like firewalls, you have in a default allow configuration, things are not patched, error messages are sharing too much data. You understand this, right? Any like hardening which is not there, right? And this is again something which comes during the testing phase when the servers are being provisioned, when the application is being designed. You need to make sure you have those strong controls there from the hardening perspective. And then once the application is launched, you need to make sure you have strong configuration practices in place to make sure that the application security posture does not get degraded. Okay, what else? Cross-site scripting. Now, cross-site scripting, this is again a very, very, I think after SQL injection, this is the most popular attack. This is also a type of injection attack, right? And but this targets web applications. It enables an attackers to inject untrusted code like a malicious script into a web page or a browser, right? And when the user navigates to the infected web page, the untrusted code gets executed in the user's browser with their permissions, and it acts like the exercise attack. It's like a vehicle for an attacker to deliver malicious code, and it's a very, very common attack. You can manipulate the output, you can redirect the user to another website, you can generate like malicious frames, take control, leakage. I mean, it's definitely one of the top security concerns for cloud developers, even on-prem developers, right? Again, the thing to protect it is through input validation and sanitization. This is the only way you can really protect against XSS attacks. Insecure deserialization. Okay, this sounds like a long thing, but basically serialization is the process of breaking down an object. You have a file, you break it down into bytes like zeros and ones, and then when it's transmitted, it gets reconstructed. So that's called deserialization, when you reconstruct it back. So insecure deserialization, that happens when an application or API, it takes like a stream of bytes which is not trusted, and it reconstructs it and becomes a potentially malicious file. So one way, malware, it hides itself. It breaks itself down to small bytes to avoid signature detection, and then relies on some later process to reconstruct it. It can have like a insecure deserialization. You can conduct a wide layer of attacks. Even remote code execution can be done by this attack. Okay, vulnerable components. A lot of time, applications, they are not built just based on the programming language. They are built on so many other frameworks, libraries, software libraries. This vulnerability happens when your application is built using like a vulnerable framework, library, or the software component. And most of these components, like it's integrated into your application. Like the log4j, if you're familiar with log4j, which happened last year, right? What happened? That was an insecure library, right? Some issue was there which was allowing the attackers to compromise. And you need to make sure that then all your components are updated. There are things like software composition analysis. When you do testing, it actually checks whether you have any insecure components present. But this is like definitely one of the hardest things to protect against, because you can have so many components, and those components can have other components to find out. So that's why it's very important to have multiple level of controls. It's largely insufficient logging or monitoring. So this is what happens when basically, like the name says, applications fail to capture, maintain, and protect all auditable events. You need to make sure you're capturing everything, right? Privilege access, login failures, and what happens. So you need to make sure that you're capturing all the data as per regulatory requirements. But what happens if you're not doing it? Then what happens if an attacker compromises your environment? You will not be able to detect it because you're not logging anything, right? And worst case scenario, even if like you get compromised, then you need logs for forensics. So this is very, very important. And you need to make sure you have some sort of a standard or strategy for monitoring logs and taking action on important security events. Okay, that completes all the common attacks. I hope you guys understood. So now we move on to threat modeling. So threat modeling is a technique you can use to identify threats to your applications, right? And how to protect them. So it's a type of risk assessment. But it's a very good way to really look at your application and what are the different risk areas. There are very, very many approaches present. Two of the most common one are called Stride and Pasta. You might come across something else called Dread. Dread is another one which is used, and you can check that. I'm going to focus on Stride and Pasta. Okay, first of all is the Stride one. So let's take a look at what it was. Okay, so Stride. Stride is like a model that was developed, I think, in Microsoft in 1999. It was used to identify and classify computer security threats. So the name Stride, it comes from like the abbreviation, right? You can see spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So it's a very important acronym because it helps you remember the 6 categories of these threats. Yeah, and you should remember this abbreviation because it might show up in the exam also, right? They might ask you what STRIDE stands for. And just a quick overview: spoofing. So the first one is spoofing, right? It's an attack during which a malicious attacker, it assumes the identity of another user or system by falsifying information, right? Like you must have seen those email spoofing, right, from phishing attacks. So that is something which you talk about when you think about spoofing. Tampering. Data tampering is like an attack on the integrity of the data. You intentionally and maliciously manipulate the data, right? You can alter data on disk, in memory, over the network, and through web applications, right? And you can tampering the data. You can basically inject yourself within and modify user credentials or other data. The whole point is to allow you to modify values and then interfere with how the application is working. Repudiation. If you worked in like banking, you would know repudiation, right? Basically, it's the ability of a party to deny that they're responsible for performing some action. You need to make sure that basically this threat occurs when the user claims they did not perform an action and you can't prove it. Like the data transaction, then they say, no, I never did this transaction. So like taking a signature, right? When you deliver a package, that's a form of non-repudiation. The delivery company, it maintains that physical record that you accepted this package. So later on, you can't say, no, I never accepted this package. So you have to make sure you have controls and logs, things like digital signatures, multi-factor authentication. All of them are there for like high risk actions to make sure user cannot say later on that I did not have this. Okay, what else is the information disclosure? This is what happens during a data breach, right? Information is shared by people who should not have access to it. And it leads to leaked data compromises, especially when you have things like PII, private health information. So you need to make sure you have things like encryption and strong access controls. Denial of service. So I talked about denial of service, I think, before. Basically, it's an attack. It denies access by legitimate users. So any application can be a DOS target, right? DOS, especially with the high availability by cloud providers. You have to make sure that you have controls to protect and monitor this. Even though most cloud providers, they have some sort of a DOS controls, but still you need to make sure your application has the proper architecture in place. And lastly, evaluation of privilege or privilege escalation. You must have heard this before. It's the last one. It's one of the highest risks. Basically, an unprivileged user is able to upgrade themselves to that of an admin user, right? And it can give you full access or the keys to the kingdom. You have access over everything and you can bypass all the controls. Strong access control is critical to protecting against this. You have to make sure that like whoever is assuming these powerful features, they are authorized for doing this, and you need to be able to detect if somebody does this. Okay, I think that completes the Stride methodology. Let's move on to the next one, which is pasta. It makes me hungry just saying this, but pasta. So like what is this? The process for attack simulation and threat analysis. Remember the abbreviation? It was developed in I think 2012, right? And it supports dynamic threat analysis. It's a methodology that integrates business objectives and technical requirements, right? And it's an attacker centric perspective of the application. You look at it from the attacker's perspective. So basically, you can count them, it has around 7 stages. In the first stage, you define the objectives, right? You define the key business objectives and critical security and compliance requirements. And you perform something like a business impact analysis, that what will happen if something happens to this application. Next is the technical scope. I mean, you can't protect something until you know it exists and needs protecting, right? You document the boundaries of the technical environment, you identify the scope, what needs to threat analysis, and you identify all the infrastructure, application, software dependencies, right? You get a high level overview of all the servers, hosts, devices that are there. Next one is application decomposition. What is it? Now you understand the data flows between the assets and the application components. You identify all the entry points and trust boundaries, right? Basically, you get a clear understanding of all the data sources and the parties that access those sources, right? Use cases, who can perform what function on which component of your application. Okay, next one is threat analysis. So threat analysis is you do a complete threat analysis. You review threat data from within your environment, from the SIM logs, web application logs, as well as externally intelligent threat intelligence fields. And like if you run like a banking app, you can find out what sort of threats are there to financial services, and you run through all those attack scenarios, right? You will have a list of all the likely attacks that can happen. Okay, after that is vulnerability and weakness analysis. So you focus on identifying all the vulnerabilities within your code and you correlate them to the threat attack scenarios. You're reviewing operating system, database, application scans, dynamic scans, static code scans, and you get like a mapping of all the attacks that are there to the existing vulnerabilities. Okay. And now we are on to model attacks, like the modeling and simulation phase. You simulate attacks that can exploit those vulnerabilities, right? And this step determines the true likelihood and impact of each attack. You'll have a strong understanding of the attack surface, what bad things can happen. And lastly, of course, is the risk and impact analysis. You take everything that you've learned and you refine your business impact analysis. You get like a full output of the prioritized risk, what needs to be remediated, and a full risk mitigation strategy. Okay, so I hope that you understood that, guys. Now we're going to move on to cloud software assurance and validation. Now, having a mature SDLC process is really important, guys. I mean, you need to unit test, audit, and verify that your SDLC process is producing secure applications that are functioning as intended, right? It's very, very important. So in this section, we're going to learn about types of testing that are there and what are the methodologies that are there, okay? You have functional testing, right? Which tests whether the application is working properly or not. But let's look at it from the security of the software. So what do we have? We have things like SAST and DAST, vulnerability scanning, penetration testing. Let's start from the first one, the static application security testing, SAST. So static code analysis is a security testing technique that involves assessing the security of application code without executing it. It's like something called a white box because it examines the source code or the application binaries to detect like where the vulnerabilities are. The SaaS tools and processes are there. They're open source, freely and commercial. They can detect you things like memory overflow, things which are very hard for humans to detect. And because they analyze source code, and your development team must be sure to find a SaaS tool that works within your particular development environment, right? And with the programming language that you're using. Now, DAST, Dynamic Application Security Testing, it involves assessing the security of code during execution. So it seeks to uncover vulnerabilities by running an application and simulating an attack against it. Like the ones we talked about, SQL injection, cross-site scripting, all those things. By examining like how the application is reacting, it is able to determine whether it's vulnerable or not. And the DAST runs against web URLs, REST APIs, against things like, for SQL injection, XSS flaws. And it's a very powerful technique to use both of them. Okay. So, and DAST is considered like a black box test because usually you perform tests from outside the application. You don't know how the application is working and how it's working internally. Okay, and the next one is vulnerability scanning. It's the process of assessing an application for weaknesses, right? You use a tool to run the tests on servers, networks, or applications, and you look for signatures that match like misconfigurations or the weaknesses. And usually what you do is you generate a report, right? That lists all the discovered vulnerabilities by severity, high, moderate, low. And in cloud environments, usually your cloud providers, it depends on what sort of service you are using, right? IaaS, PaaS, or SaaS. It impacts what your responsibility is. Like for the SaaS or the PaaS, like the CSP will be responsible for patching the underlying operating system. For infrastructure as a service, customers will be responsible for vulnerability scanning the virtual machine and the instance and the databases. And with the SaaS, the cloud provider is doing everything, right? So it depends. You should check your CSP customer responsibility matrix to make sure, right, who is going to do what. And the next one is penetration testing. So penetration testing is it's the process of conducting a simulated attack on a system or application to determine like what can be exploited, right? It can be white box, it can be black box, and it's for the good guys to discover like what are the exploits, and it can give you a lot of good insights into what the vulnerability is. And please do not confuse vulnerability scan and penetration testing. Penetration testing is like automated, right? Vulnerability scanning is automated with a tool, and usually it's just a report. But penetration testing, they use the VScan and the other tools, SASDAS, to determine vulnerabilities, and they exploit it. So please, I've seen a lot of people getting confused between the two. They're not the same. Okay, verified secure software. Now, we've talked about how to validate it, right? And what do you call? So how do you know like all the components which are there, like everything which is going within your software development life cycle? How do you know that it is? And a lot of those times, especially within cloud environments, they're not completely within your control, right? So in this section, we want to explore the use of what are the tools like approved APIs, supply chain, and the other things which are there. How to make sure that no insecure software has come in within your environment. Okay, so how to verify? Well, there are numerous ways. First, we talked about APIs, right? APIs are exposed. Cloud providers give you access to APIs, and you can programmatically access and control services. But at the same time, the security of APIs it plays a big role in the overall security of cloud environments and the applications. If you are consuming unimproved APIs, it can lead to insecure applications. So, as a CCSP, you must make sure that your organization has a formal process for testing and approving all APIs before they use them, right? Just like any application, you need to check, you need to make sure that API security is there, what sort of protocols it's using. I have a complete like a free course on API security. You can check that out also on my channel. Okay, next one is what? Supply chain management. Now, supply chain management, it's an increasingly common. Most companies, they don't like build everything from scratch, right? They integrate pieces of code or entire applications from other organizations into their own applications. So cloud applications tend to be composed of multiple different external components and API calls, and they leverage software and libraries from one or more cloud providers and external sources, right? The problem is if those components are insecure, right? And you don't they people a lot of time people use software without understanding where it's coming from, what are the software is, and they haven't validated it. So you need to make sure you are using things like software composition analysis, which I talked about. That will let you know if there's any insecure component within your SDLC. Okay, third party software management. So supply chain management, right? When you talked about supply chain management, it has to do with your use of third party applications. And you should also take a look at like what third parties can what part of their software they're managing, right? Like third party may be patching, third party may be doing encryption software, access management, all those other applications you need to take a look at, right? Because if those applications get compromised, they can compromise your application also, right? And lastly, validated open source software. So open source is a reality, right? It's widely used by individuals and organizations across the world. And in cloud environments, especially, there's a heavy reliance on open source applications, libraries, and tools to build your own software. So a lot of times people say open source software is considered to be more secure than closed software because it's publicly available and heavily reviewed. And public source software, it gets a lot of security and like scrutiny because bugs are found in much faster, right? And a lot of times this is true, but for highly regulated companies like government agencies, you can't just go ahead and use open source software, right? So you have to take a look at it like from any other software and properly assess it, do a risk assessment, make sure it's being scanned. But these are the things you need to look at when you think about verifying your security of your software. Okay, now we've moved on to what is this? Is cloud application architecture. So when you talk about cloud applications and the security, right, it involves more than just a development environment and doing testing, right? So when we talk about this cloud application architecture, we're talking about other types of controls from your cloud like environment, like encryption, sandboxing, and we're going to discuss these things. This is basically the concept of defense in depth. What other tools are there, so you don't just depend on one thing, right? You have multiple other security layers that are providing you layers of security to make sure that nobody can compromise your application. Let's take a look. What are we talking about? Well, we're talking about things like firewall, right? Firewall is pretty much like a core component. Whether it's on-prem or cloud, you need a firewall, right? And what do you call these are usually devices which are located at strategic points throughout a network to control the traffic in and out, right? And untrusted traffic is blocked. Of course, in cloud environments, you can't just walk into a CSP data center and put your own firewall, right? Usually, you have virtual firewalls, and most CSPs, they offer virtualized firewall vulnerability, virtualized firewall functionality. Sorry, and they give you software-based versions, and they can be used for any type of model like SaaS, PaaS, and as you have to just take a look at how it's working, right? Again, other is web application firewall. So web application firewall, it's like a security appliance monitor. It's like a firewall, but specifically towards application level, right? At the HTTP layer 7, which they say where all the application attacks are happening. So this is like things like cross-site scripting, SQL injection, other application vulnerabilities in the OS top 10. So this is like a very configurable, and they give rules to make you sure that these sort of attacks are being protected. As cloud security professionals and application developers, they have to work together to make sure that the WAF is configured properly without any functionality being lost. Okay, what is malware and threat protection? This is pretty simple. I mean, this is pretty much back to the olden days, right? You need to have so proper malware protection, things to make sure that no zero-day exploits are happening, no malware can come in and just compromise your server which is not patched. Okay, what else is there? Encryption. Now, encryption is another central component of every cloud security strategy you read throughout this book, right? We've talked about it before. You need to make sure that you have encryption happening at the file, object, database, volume level, and of course at the what do you call transmission level also. Like SSL is there. Any data which is being transmitted through VPN, it has to be through TLS between an application server, client browser. Basically, encrypt as much as you can without impacting the performance. Like I said, what the Amazon CTO said, right? That you should encrypt, like you should dance like no one's watching, but you should encrypt like everybody's watching. And I thought that was a very good phrase because that's how you should be thinking of, like when you talk about security. Okay, what else is there? Sandboxing. Now, sandboxing is the process of isolating an application from other applications by placing it in a separate environment, like a sandbox. What you do is you isolate the application, right? So what happens is you reduce the blast radius. So errors or security vulnerabilities in the application are also isolated within the sandbox, and you're protecting the rest of the environment from harm. So you can like mirror the full production environment or be limited to like a stripped down services. But basically, you're running untrusted, untested code, and it's very important in cloud environments where you don't have the ability to physically separate resources. Virtual machines, they're like an example of sandboxing, right? And just you have to make sure that the traffic is isolated, because you don't want something, you think it's something is being sandboxed, but it's actually not, which leads to later on to a security incident. Okay, application orchestration and virtualization. They are again two key components that center around building and using application components, but with different purposes. Like application orchestration, application virtualization is the process of encapsulating or bundling an application into like a package, which is isolated from the underlying operating system. So this form of it's a type of sandboxing. It allows the application to run on a system without needing to be installed on the system, which enables it to run on virtually any system. Like even if the operating system is not supported, you can run it, right? It just runs like it's basically you're tricking the application into thinking it's running directly on hardware, right? And it's like it allows you to test applications in a known environment without posing a risk to the rest of the environment, right? So you can run Windows applications on Mac or vice versa. So it uses for few. This is a very like important technique which is used within the cloud. Okay. Of course, you need to think about like how else is happening, like what else are the threats which are happening and how the problems can happen also. And next one is application orchestration. So this is the process of bundling and integrating two or more applications or services to automate a process. You basically configure, manage, and coordinate a workflow between multiple systems and software components in an automated fashion. You basically are using technology to like align your technology stack with the, like certain business requirements, right? You're automating configuration management of disconnected applications and services. So using orchestration to do that, right? It might sound like automation, but the terms are not synonymous. Automation usually refers to a single task being automated. With orchestration, you are making like a complete workflow across multiple applications and systems, and you can automate many different processes. You can provision resources, create virtual machines, all those things, right? If you've ever used things like Terraform, CloudFormation, it's a very popular way of doing this. Okay, we're reaching like the end of the things. Now we're talking about identity access, right? And when it comes to application security, identity and access management is very, very important, right? Because it enables you to identify users, give them the proper permissions, grant, deny access, and there are many, many things which go into creating an IAM solution. So we're going to look at all of them. Let's take a look at federation. Now, the concept of federation, we talked about this earlier also. It's very, very important in cloud environments. Basically, you manage user identities across multiple systems like on-prem, cloud-based, and a federated identity means that the user's identity is linked with their identity on one or more systems, right? So basically, you're authenticating to one system, and that trust is being used to let you log into other applications also. And this type of federated identity management is enabled through a common set of policies and standards that allow you to basically use it. And it's a very, very powerful. Some of the common standards are SAML, OAuth, OpenID. We talked about this earlier. We're going to take a quick revision on this. But basically, you have to think about identity providers like a trusted third party, which has all your user IDs and passwords, and user using that to authenticate. And then other applications are allowing you to log in, right? Like the easiest example I can give you like is like the Gmail, right? Or the Google suite of services. You log into Gmail, you can log into Google Drive, Google Meet, because you're already authenticated, right? You don't need to keep on authenticating. So this is what we are talking about here. So what are the federation standards? We have things like security assertion markup language. It's like a XML based standard. It's used to share authentication authorization information between identity providers and service providers. It's like a markup language, right? Basically, it asserts that the user is trusted, and it sends like assertions to the SAML assertions that gives you all the information you need to authenticate a user, and other applications rely on this assertion. They say, okay, this guy has been authenticated by the SSO as SAML provider, and he can be allowed access. Okay. What does it say? OAuth. We talked about OAuth before. It allows, it's basically is access delegations, authorization, right? And it allows you to, instead of what do you call it, it gives you, it vouches on your part, right? When you use things like Google or Facebook, it allows you to share certain information about your account with third parties, and you don't have to share your credentials, right? Lastly, OpenID. This is like for authentication. It's a decentralized authentication protocol that allows you to participate in like other applications can participate in this, and it allows user to log into multiple web applications with using one set of credentials. There may be user ID, password, smart cards, other things, but you're able to exchange authentication information between the rest of them. Okay, single sign-on. Now, single sign-on, we've talked about this before, right? And it comes into federation, but the same thing. Basically, what happens is you log in once, and then you are allowed access to multiple applications. You don't need to maintain data about other applications, right? And federated identity, it's just like a type of single sign-on only. But basically, this is how what do you call you work? You're sharing the same credentials across multiple applications, and you don't need to manage like your different sort of credentials for each time. Like the same example I gave you earlier about Google account, right? You can access Gmail, Google Drive, YouTube, all other the Google services without having to sign in again and again. Okay, multi-factor authentication. Multi-factor authentication should be very easy. I mean, I'm sure you've worked on this before. I mean, if you've ever even used anything like with a mobile application, right? Basically, it's relying on two or more authentication factors. People usually just use the user ID and password. You add more things to that, like something you have, right? Like a token, or something like a PIN, or something you are, like a biometric, right? All those things need to take an amount, and they strengthen the application. Like we talked about multi-factor authentication, like a token or like a biometric thumbprint, all of this. So even if your password is compromised, the attacker is not able to access because he does not have the other factor also. So it's a very basic security concept. I'm not going to spend too much time on this. Okay, what is the last topic? We almost reached the end, which is cloud access security broker. So, a lot of times people used to think that the cloud is inherently insecure because we can't access the data. Data can be accessed from anywhere. So this is where, the cloud access security broker comes in. It's like a CASB. That's how we say it's a software application that sits between the users and the cloud services, and it actively monitors our cloud usage, and it makes sure that you're enforcing security. This is like a very powerful tool. It stops people from data leakage, malware, and alerts you about what is happening. So at a minimum, it gives you like visibility, who is doing what within your application, like BYOD and all that, right? data security. So you can actually see who is doing what, right? Who is copying data in and out, and you can enforce your DLP things. Threat protection, it gives you a full 360 degrees view on what is happening. Compliance also, like things like PCI DSS, HIPAA, GDPR, right? And you can enforce zero trust also. So to make sure that at every what you call request is being authenticated. And CASB is usually to operate in multiple modes, 3 modes to be precise, which one is reverse proxy, forward proxy, and API mode. So let's take a look at reverse proxy. In this mode, reverse proxy, CASBs, they operate in the data path. So what they do is they intercept every request, right? And they inspect all the traffic which is coming there, and they're able to enforce DLP policies in real time and prevent malicious behavior. This is like the ideal CASB architecture, and usually it requires an SSO. You need an SSO solution to be there, and once you authenticate, the CASB kicks in and it'll make sure that everything is being authenticated, right? Other one is forward proxy. This type of CASB sits on the user's desktop or mobile phone. It's it securely inspects and forwards all the traffic for the user. And this usually requires to install certificates on every device that needs to be monitored. It becomes like a challenge to deploy in large distributed organizations, right? Usually require an agent. And it's good if you have partners and everything, but usually it's not very practical if you have a large distributed users. Lastly, which is API mode. So this is basically API mode, you can say read-only mode. It monitors data within the cloud. Instead of being in a data path, you don't have to install anything. It just plugs into the cloud provider and starts monitoring it. The good thing is very easy to do without any interference with the user actions. It's just basically hooks and starts monitoring. The bad thing is it's not real time. Usually it's difficult to prevent. It can't really stop things from happening. It can monitor and let you know what's happening. So this covers CASB, right? I believe we've reached the end of the domain. Yes, guys, I hope this was useful to you. You understood. Like I said, it's a lot of concepts to gather. Just go step by step, make your notes, try to understand. If you face any issues, just let me know in the comment section. I'll be happy to clarify. Thank you very much, guys. If you found this useful, please do like and subscribe to this channel and comment and share this video. Thank you very much, and I'll see you.